Students, in this lesson, we will mainly learn about an important piece of equipment in catalytic cracking. The regenerator. The main function of the regenerator is to burn off the coke deposited on the catalyst, thereby restoring its activity. It also provides the heat required for the catalytic cracking reaction. The regenerator shell is a large steel cylinder. The upper part is the dilute phase zone, and the lower part is the dense phase zone. The maximum diameter can reach 16.8 meters. The main requirements for the regenerator are the carbon content on the regenerated catalyst should be relatively low, generally required to be below 0.2% or even below 0.05. It should have a high coke burning intensity. When based on the effective catalyst inventory in the regenerator, the coke burning intensity is generally 100 to 250 kilograms per hour. Catalyst deactivation and attrition should be minimal. It also requires easy operation, low energy consumption and investment, and the ability to meet environmental protection requirements. In industry, the main forms of regenerators can be divided into three categories: single-stage regeneration, two-stage regeneration, and fast fluidized bed regeneration, to ensure that the combustion air, often called main air in plants, enters the bed and distributes evenly across the entire cross-section. An air distributor is installed in the lower part of the regenerator. Distributors can be divided into plate type and tubular type. The air distributor is equipped with nozzles inclined downward at 45 degrees. Air is ejected downward from the nozzles. In this way, catalyst cannot enter the distribution pipes. The air then returns to the upper bed due to coke combustion in the regenerator. Excess heat is generated. It is necessary to remove a portion of this heat to maintain the heat balance of the two stages reactor and regenerator. The heat removal method can use the approach of adjusting the catalyst withdrawal rate to change the cooling load. Its operational flexibility can vary from 0 to 100%. This makes the regenerator temperature an independently adjustable variable, which can adapt to the reaction system's heat balance needs under different conditions. The heat removal equipment in the regenerator includes internal heat removal type, where the tubes are set inside, which has poor operability and is prone to damage. Generally, we adopt the second type, external heat removal type. It relies on water inside the tube bundle to remove heat. The forms of regenerators commonly used in industry can be broadly divided into three categories. Let's first look at single-stage regeneration. Single-stage regeneration uses only one fluidized bed regenerator. Its characteristic is that the regeneration temperature has a very significant impact on the coke burning reaction rate. Increasing the regeneration temperature is an effective means to increase the coke burning rate in single-stage regeneration. The temperature of the dense phase bed generally does not exceed 730 degrees Celsius. The main problem with single-stage regeneration is that the increase in regeneration temperature is limited by equipment material, and the effective catalyst carbon content in the dense phase bed is low for two-stage regeneration. As the name implies, unlike single-stage regeneration, two-stage regeneration divides the coke burning process into two stages. Compared with single-stage, the main advantages of two-stage regeneration are: for a complete mixed bed reactor, the carbon content on the semi-regenerated catalyst from the first stage outlet is higher than that of the fully regenerated catalyst, thereby increasing the coke burning rate. In the second stage regeneration, fresh air or higher temperature can be used to increase the coke burning rate. The water vapor partial pressure in the second stage can be very low, reducing catalyst hydrothermal deactivation. Furthermore, the catalyst inventory in the second stage is lower than that in single-stage regeneration, and the residence time is also shorter. Therefore, a higher regeneration temperature can be used in the second stage. Another type is the fast fluidized bed, also known as circulating fluidized bed regeneration. Its characteristics are: first, the gas phase becomes the continuous phase and the catalyst particles become the dispersed phase, thereby intensifying the coke burning process. As the gas velocity increases, the back-mixing degree decreases, and the flow in the middle and upper parts approaches plug flow, which is also beneficial for increasing the coke burning intensity. In the fast fluidized bed region, a large solid circulation rate is necessary to maintain a high bed density. The coke burner regenerator in a catalytic cracking unit is one regeneration method belonging to the circulating fluidized bed type. In order to maintain the density of the dense phase zone in the coke burner at 70 to 120 kilograms per cubic meter, a large flow of catalyst is introduced from the second dense bed through the external catalyst circulation line. The circulating catalyst also plays a role in increasing the ignition temperature within the coke burner. In this lesson, we mainly explain the structure of the regenerator and its types. Goodbye, students.